Introduction to the Scientific Revolution. The scientific revolution of the 16th and 17th centuries was an extremely formative period in the history of human civilization. But surprisingly, given its significance in shaping modern-day science, there is a great deal of misunderstanding concerning what took place over those few centuries in Europe. In this lecture, we will overview some of the general characteristics of the scientific revolution, and then look at how science changed during this period, concentrating on the movement away from the Aristotelian view of nature and the accompanied increase in the use of mathematics to describe the workings of nature. We will also discuss the famous historian Herbert Butterfield's influential views on the impact of the scientific revolution. It is important to emphasize that the scientific revolution did not mark the birth of science. Instead, the origins of science reach back thousands of years to the ancient civilizations of Mesopotamia and Egypt. It should also be noted that the term science did not gain its modern meaning until the 19th century. Prior to that time, and thus during the scientific revolution, the term natural philosophy or philosophy of nature was used to designate what today we would call science. Natural philosophy is a term with roots stretching back to Aristotle in ancient Greece. Ancient and medieval scholars used the term to signify investigations into the natural world and the material causes of natural phenomena. Natural philosophy included, among others, the disciplines we call chemistry, physics, biology, physiology, and meteorology. However, interestingly, ancient and medieval scholars saw the disciplines of mathematics and medicine as being outside the domain of natural philosophy. It was not until the scientific revolution that mathematics was seen as a proper and in many cases integral tool for describing nature. The scientific revolution took place in Europe over the years 1500 to 1700 and was a period which saw remarkable advances in virtually all areas of science. Some mark the beginning of it in a somewhat arbitrary manner, as coinciding with Nicholas Copernicus's development of the heliocentric or sun-centered universe, a theory he put forth in his book on the revolutions of the celestial spheres, which was published around the time of his death in 1543. While there were many factors contributing to the remarkable growth in science at this time, the influence of the Renaissance is often seen as one of the most important. The Renaissance, which began around the 14th century, was a period in European history of great cultural and scholarly development. This period saw the invention of the movable printing press, the exploration of the New World, and the rise of the scholarly movement known as Renaissance humanism. Humanist scholars were very interested in the works of ancient philosophers, and were responsible for the rediscovery and translation of hundreds of works by ancient scholars, including many of Plato's dialogues. Humanist scholars also translated many ancient works on mathematics, works which were to have a great influence on the philosophers of the scientific revolution. While the scientific revolution began in the 16th century, the majority of the major achievements were seen in the 17th century. This was the time which saw the work of such giants as Galileo Galilei, Johannes Kepler, René Descartes, and Isaac Newton, to name but a few. The 17th century also saw widespread abandonment of Aristotelian natural philosophy, which up until the time was the most influential natural philosophical system the world had ever seen. To understand why the abandonment of Aristotle's system is seen as such a momentous event in the history of science, it will be beneficial to briefly examine the impact it had on the natural philosophy of the Middle Ages. Soon after the fall of the Western Roman Empire in the 5th century AD, Aristotle's works on natural philosophy became largely lost to the Latin West. However, beginning in the early 12th century, a great translation movement commenced, which saw the reintroduction into Europe of many ancient Greek texts from Arabic and Byzantine sources. Included among these were many of Aristotle's works on natural philosophy. Aristotle soon came to be the most influential ancient philosopher of the Middle Ages. Dante, the Italian poet who was born in the 13th century, referred to Aristotle as the master of those who know, while to many Christian theologians he was simply known as the philosopher. Theologians such as St. Albertus Magnus and St. Thomas Aquinas incorporated the Aristotelian philosophy with Christian theology in the 13th century to help develop what was to become known as scholasticism, a system or method of thought which was to dominate many European universities well into the 17th century. In fact, many of the giants of the scientific revolution, including Descartes, Galileo, and Pierre Gassendi, were educated in the scholastic method, a method whose downfall they contributed to. The Aristotelian system was extremely comprehensive, which was one reason for its endurance. However, many elements of it were challenged during the scientific revolution. A good example of one aspect which faced many challenges was Aristotle's view of the cosmos. His view of the cosmos was to face strong challenges by astronomers such as Copernicus, Kepler, Galileo, and Newton in the 16th and 17th centuries. The works of these men finally secured the abandonment of the geocentric or Earth-centered universe, a view Aristotle favored, and the adoption of a heliocentric or sun-centered universe. Aristotle's geostatic view of the universe, one in which the Earth remains stationary, was also abandoned in favor of geokineticism, geokineticism being the claim that the Earth exhibits motion, both diurnal motion on its axis and annual motion around the sun. The heliocentric and geokinetic hypotheses were put forth by Copernicus in his work on the revolutions of the celestial spheres in the 16th century, but it was not until the further work by men such as Galileo and Newton in the 17th century that these views became increasingly accepted. Aristotle also emphasized the division of the cosmos into two realms, but this view was also largely relinquished by the end of the scientific revolution. These two realms which the universe was supposedly divided into were the terrestrial realm and celestial realm. The terrestrial realm, according to Aristotle, was the region below the moon and included the earth. This realm was made up of the four elements, earth, water, air, and fire, and characterized by change. The celestial realm, on the other hand, the region above the moon, included all the stars and planets, and was seen as unchanging and composed of a fifth element. However, with the growing use of the telescope during the scientific revolution, astronomers found increasing evidence that countered Aristotle's claim that the celestial realm was unchanging. The scientific revolution also saw a decline in emphasis on qualities, a marking feature of Aristotle's natural philosophy, to an emphasis on quantity. To make the distinction between quantity and quality clear, a good analogy is to think of the different ways one could describe a tree. As a description, one could offer the tree's qualities, such as its color, texture, or shape, or alternatively, one could describe the tree using quantities, such as its weight, height, the length of its branches, the number of leaves it has, and so on. During the scientific revolution, natural philosophers became increasingly concerned with using quantity to describe nature, and this emphasis on quantity went hand in hand with the growing role of mathematics in natural philosophy. As we mentioned at the beginning of the lecture, mathematics was for a long time seen as outside the realm of natural philosophy. But philosophers such as Copernicus, Kepler, Galileo, and Newton increasingly made use of mathematics in their natural philosophical works. Galileo probably uttered the most famous statement on the role of mathematics for understanding the natural world when he stated, "This grand book, I mean the universe, is written in the language of mathematics, and its characters are triangles, circles, and other geometrical figures, without which it is humanly impossible to understand a single word of it." The philosophical system which largely came to supplant the Aristotelian worldview and emphasized quantity over quality is called the mechanical philosophy. John Henry nicely explains the basic tenets of the mechanical philosophy in his book, The Scientific Revolution and the Origins of Modern Science. All phenomena were to be explained in terms of concepts employed in the mathematical discipline of mechanics: shape, size, quantity, and motion. The mechanical philosophy saw the workings of the natural world by analogy with machinery. Change was brought about by and could be explained in terms of the intermeshings of bodies, like cogwheels in a clock. The move away from Aristotelian natural philosophy, the increased use of mathematics to describe the natural world, and the rise of the mechanical philosophy were all very significant for the future development of science. The changes were seen as so significant by the famous 20th century British historian Herbert Butterfield that, as Kenneth MacIntyre says in his book Herbert Butterfield, History, Providence, and Skeptical Politics, according to Butterfield, the two most significant intellectual events of the modern period are the emergence in the 17th century of the scientific worldview and the emergence in the 19th century of modern historical consciousness. Butterfield also suggested that the scientific revolution led to the emergence of a new belief which now characterizes the way modern humans look at the future of human civilization, this being the belief in the doctrine of progress. Prior to the 18th century, the quality of life from generation to generation stayed largely the same. However, ever since the theoretical advances achieved during the scientific revolution began to see practical uses in the form of new technologies, living standards have increased at a dramatic pace. This has led to the idea that humans have entered a new stage of development, one in which continued scientific advances will lead to unending social and cultural progress. This idea of unending and inevitable progress is today accepted unquestioningly by many. However, belief in a doctrine of progress was absent prior to the scientific revolution. So to conclude, while the scientific revolution was not the period which saw the birth of science, or the first period to experience significant scientific advance, it was a period which saw remarkable individual achievements in natural philosophy by men who are now viewed as giants of the field. It was also the period which saw the overthrow of Aristotle's natural philosophy and an increase in the use of mathematics to describe the natural world. These two changes have undoubtedly had a remarkable impact on the development of science up until the present day. And along with the many other changes to science which took place in the 17th century, some have come to view the scientific revolution as one of the most formative periods in the history of human civilization.